Welcome to my video. So how do we solve for x? If you'd like to try yourself, just pause the video, try it yourself, then come back and I'll show you how it's done. Okay, so what we have here is quite plainly a complex number problem. We have I, which is the imaginary number, which is the square root of -1, and here we have ln of -1, which doesn't exist in the real world. So what process do we use involving complex numbers to solve this? The way I found the easiest way was polar coordinate form of complex numbers. There's a lot of information on the internet or YouTube to find out more about the polar form of complex numbers, but briefly, if we draw our complex plane, we have the real axis here, the imaginary axis vertically here. Draw a unit circle. This is our origin. Any point on this circle, so we'll choose this point here, any point will have a real component and it will have an imaginary component. So if we were to draw a line and call that, say, alpha, our complex number here will be simply the cosine of alpha plus I times the sine of alpha. This because it's a unit circle and the hypotenuse here is 1. Okay, now that's the Cartesian form of complex number. We have a real part and an imaginary part. So how do we go to the to the polar form? Well, if we look at the Taylor series for cos and the Taylor series for sine, and add them together with the sine series multiplied by -1, we actually get another Taylor series, and it is actually for the exponential function, but it's e to the I alpha. So this is quite convenient, certainly for solving our problem here. So e to the I alpha is equal to cos alpha plus I sine alpha. So we can represent the imaginary number I by e to the I pi on 2, where the angle alpha here is pi on 2. We work in radians with all of these complex number issues. And the number -1, which would be here, this is +1, this is I, this is -I, being a unit circle. So -1 is equal to e to the I pi, because the angle alpha here would then be pi radians. You've probably seen this, pardon me, you've probably seen this expression before, e to the I pi plus 1 equals 0. You've probably seen that before. Okay, so another way this polar form could be used is, say we wanted the square root of -1, we all know is I. This is exactly the same as saying the square root of e to the I pi, but because the exponent, we're dealing in the exponent here, we just divide by 2, which is what we normally do for doing the square root, so we end up with e to the I pi on 2, which is I. So this makes working complex numbers quite easy and quite straightforward. So how does this all help us solve our problem? Well, let's write our problem down again. So it's I to the x equals the natural logarithm of -1. Now, a lot of this involves the substitution of these two expressions here. So we can start with the right hand side. So this will be a natural logarithm of e to the I pi, which is being -1. Now quite conveniently we have a log of an exponential, and they both cancel each other out being reciprocal functions, so this is quite easily equal to I pi. So our problem now resolves down to just simply I to the x equals I pi. So we continue with our little technique of substitution. And what we find is, doing the right hand side again, if we take the log of both sides, actually we'll do the left. If we take the log of both sides, we have x ln of I equals the natural logarithm of I times pi. And because they're multiplied together, we can separate them out to ln I plus ln of pi. And again we can substitute in for I, and it becomes ln of e to the I pi on 2 plus ln pi. And the log and exponential cancel out, giving us I pi on 2 plus ln of pi. And we can bring this down now, so we have x ln I. And as we showed just then, ln I is just I pi on 2, so we have x I pi on 2 equals I pi on 2 plus ln of pi. And now to find x, we just simply divide by this factor here. Divide both sides by I pi on 2. Now, curious property of I, I'll just put this as a subnote, I is equal to its negative reciprocal. It's quite easy to show. You can prove that for yourself quite easily. I won't do it here, but we'll just take that to note for the moment, because what we will show is that x is equal to minus I multiplied by 2 multiplied by our I pi on 2 plus ln of pi, all divided by pi. Now if we carry our I through the parentheses, we have x equals I times I is minus 1, with the negative is plus 1, and the 2's cancel out, so we end up with just pi, plus ln of pi times minus 2i, all divided by pi. Okay, so the pi's cancel out, we have 1 plus, actually we'll just take the negative to the other side, so instead we will say 1 minus 2i ln of pi divided by pi. So that is our answer for x. You can actually check this with Wolfram Alpha if you like. I should have mentioned also, with all of these expressions for exponential expressions, because the circle can be traversed multiple times, this angle can actually have 2 pi added to it and give exactly the same result. So you can have any multiple of 2 pi added. So actually an infinite number of solutions to this, simply by going around the circle any number of times. But for the solution I have here, we'll just take the primary solution, where the number of revolutions is just 0. So this is our result. X equals 1 minus 2i times log of pi divided by pi. I hope you got the same answers that I did, so thanks very much for watching my video.